Right, so I get the pleasure of chairing the session about AI, which is absolutely a topic of the moment. And I think we've all heard that AI is going to fix everything. Not really. But it is indeed a new technology that is here to stay, and there is a lot of investment going into it. In fact, I think the NHS has invested over £250 million in the AI lab. And there was a very interesting report released in April 2025 for those that want to read it. But I thought it was useful to summarize some of the findings, which will not be surprising to anyone here. AI is already improving diagnosis, accelerating imaging, and supporting clinical decisions. We know that. But scaling those successes across the NHS has proven harder than what we imagined. The barriers aren't necessarily technical, they're structural. Procurement, regulation, data access, and the sheer complexity of the NHS is all part of the problem. That's why these programs struggle to scale nationally, not because the technology isn't ready, but because the system isn't always ready to adopt it. That's not a failure, it's just a reminder that the progress in healthcare comes from alignment across policy, leadership, infrastructure, and people. So AI is not the answer to every problem. It can't fix workforce shortages just yet, waiting lists, or even your coffee machines. But there are real problems that it can help resolve. If we're brave enough to cut through the hype and smart enough not to dismiss it because of past disappointments. So today, we'll hear from speakers who are doing exactly that. They're exploring how we move from experimentation to execution, and from promise to practice, and from vision to something real and not just a hallucination. So without further ado, I would like to invite Sam McInerney, who is a PhD student and the founder of doctors.code.com.
Thank you. Good afternoon, everyone. Lovely to be here. Thanks, Mark, for inviting me along. When Mark first asked me to do this talk, I was doing my scoping review at the time, and I thought, I'm going to talk about fine-tuning approaches and performance evaluation in large language models. And then I looked at the lineup a couple of weeks ago, and I thought, 3 o'clock slot, I'm going to put everyone to sleep. So you'll be very thankful I've changed my talk entirely for today and for the audience. So essentially what I'm going to be talking about is the work I'm doing with real-world data, oncology data, and utilizing large language models. Some of the challenges that we're going to have implementing this type of technology into the NHS, and also some of the wins that I've had so far. So, by the way, I'm Sam. I'm an Oncology Register. I hit my chest there because it made a really loud noise. I'm a PhD. I'm doing a PhD in cancer and AI at the University of Edinburgh, and I'm also a computer scientist as well. So here's my disclosures, and I just wanted to say special thanks to Datalock and NHS Lothian. It's because of the special agreement that they have and my PhD that I'm able to actually work with real-world data. It's quite a unique and unusual situation that I'm in. So thank you to them. So my days as a software engineer taught me that every good solution starts with an exceptional understanding of the problem. So I'm going to tell you about the problem and why I'm doing this PhD. And the problem is cancer has a capacity crisis. So we're diagnosing more people with cancer. You probably know this from the bus stops that tell you how many people are getting prostate cancer and all the rest of it. The incidence is going up. And alongside that, we have more and more treatments, immunotherapies, chemotherapies, conjugate therapies, and they are actually increasing survival, which is fantastic. But I think you can probably see where I'm going with this. More people getting diagnosed cancer, more treatments to give, and they're all living longer. And the NHS has a capacity crisis. And in some parts of the UK, we're actually having to have conversations about potentially withdrawing treatments or holding back and only giving it to certain groups. And I can assure you, that is a conversation no oncologist or patient wants to be on the end of. Okay, and this problem of capacity is really compounded by complexity. Now, there's a lot of medics in this room. I think it's true for all specialties, but especially for oncology. Medicine's getting harder. I don't know if you think this, but it's getting really hard. Right? We are doing more genetic testing. These genetic tests, they're telling us what kind of treatments we can give. We're relying on biomedical tests. We're using more treatment modalities, I've already mentioned. We're using more imaging, so we're using CT PETs and MRIs just for clinical encounters now. And there's a constantly evolving landscape of new trial data, new drug approvals, new best practice guidelines, and it's really hard to keep up with all that. And at the risk of beating the dead horse that we've all been talking about, you've got fragmentation from our electronic health records. When I see a patient in clinic, I need all this information about them, all the things that we've talked about. It takes me ages to find all this. It's not all in one place. You have to go hunting for it. And this amount of fragmentation, this amount of search, it wastes so much time. And we go across these disparate systems, it's inefficient, it's cognitively demanding, and the literature shows that it's actually leading to mistakes being made, okay? So it's something we really need to take seriously. So my research question is essentially, can LLMs, large language models, help solve this problem of complexity, capacity, and data fragmentation, thinking about some sort of workflow optimization? All making sense so far? Good stuff. Great. So you look at the literature and you see stuff like this and you think, we've cracked it, we're already there. But this is not the case at all. And this was from a Nature paper in 2024. And essentially, it's suggesting that we can use this technology now. But this study was based on a public data set, the MIMP3 data set is very commonly used. It was a single ICU encounter with discrete episodes. That is not what real-world data looks like at all. You've got lots of different players there. You've got different healthcare specialists. You've got pharmacists, administrators. Everyone's putting their own bit of information onto this electronic health record. So if you want to pull this information out, you're going to have to do some real clever stuff there. There's duplication, inconsistency, redundancy, and let's not forget there's personalities in there, people who just don't even document, which I'm sure we've all come across. So that's part of the problem, but the bigger issue is actually data access. So these models aren't drag and drop. You can't just use something that's been trained and developed outside of the data that is going to be used. The LLMs are only good with the data that they're trained and used on. So getting access to this data is a real problem, but we don't really know how to do it yet. No one's able to get it. Information governance doesn't really understand the technology, and it's new technology, so we don't really know how to regulate it either. And we don't understand the risk. And I can attest that the last year of my life has basically been an uphill struggle with IG, trying to work out how we can safely use a model inside the NHS infrastructure. So, the large language model. This is the fun bit of the talk for me. Anyone use ChatGPT? Wonderful, I was expecting more hands. Yeah, there we go. Right, so ChatGPT is amazing, isn't it? Absolutely fantastic. You think, oh, if I could plug that into the NHS or put my patient information into there. Never going to happen. In a million years. Here's why. You cannot send patient data to a data center in Utah. And without getting political, what on earth are they going to use that information for? We don't know. We cannot do that. It's not allowed. So if we're going to use a large language model, we have to really think about how we're going to use it and what kind of language model. Now, it has to fit within the NHS's infrastructure. And some of these language models are really complex. They're big. They take a load of processing power, especially when you want to do stuff like fine-tune them on patient data. So we need open source language models. They need to be brought into our infrastructure. And the NHS isn't Google. So we're not going to have these super powerful computers that can run across massive clusters of GPUs. So the thing we've really got to think about is any of these solutions have to really work within the resource constraints that we have. I've got a lot to say about this. Have I got time? I've got 10 minutes, right? Just 10 minutes? We've got a bit more? 3 minutes, Jesus. Okay, so really exciting. So to add to this complexity, you have to basically beg to use a language model. And I have to filter around trustworthy models. You have to use one that is going to fit inside the system. So I was given approval to use Llama 3.1, which you'll see there's a lot of literature out there. It's fairly small. It works really well. But the problems don't stop there. There's a couple of flavors of Llama 3.1. there's an 8 billion parameter version and a 70 billion parameter version. And just to like give you a little bit of a deep dive, because this is really cool stuff. So the way to think about parameters is they're like the grey matter of the brain. I think we have a neurologist in the crowd, so I hope I'm not making myself sound stupid. But it's the amount of connections. You give this model the same bit of information, and one will make 8 billion connections, and the other one will make 7 billion connections out of it. That's the kind of idea. So obviously you think, I want the 70 billion version. It's going to be better, especially for this big oncology data. But the problem with that is, if I take the same patient record with a metastatic patient who's got 200 records and I put it through the 8 billion version, it takes maybe half an hour. If I put it through the 70 billion version, it'll take about 3 hours. And if you've got 25 patients in your clinic, that's never ever going to work, right? So you've got to think of a way around that. Here's the thing, though. There's something called quantization. I'll very quickly touch on this because it kind of gives you an idea of how these models work, and I think it's amazing. So you can actually reduce the size and the processing power and the time taken by putting these models through something called quantization, which is where you reduce the accuracy. Now, humans can really think about 3 or maybe 4 dimensions, so X, Y, Z, and maybe time as well, right? So the Llama 70B model has 8,192 dimensions, which is mind-blowing. So every single bit of a word that it reads and sees, it has coordinates to 8,000 coordinates, essentially. And what quantization does is it reduces the accuracy of each one of those coordinates, each one of those 8,000 coordinates, by decimal places. So instead of 7 decimal places, it goes down to 3. So you can speed it all up. The whole thing takes less time. And what you're doing is you're just basically taking that error down from 7 decimal points to 3. And chatbots are essentially, large language models at chatbots, they're just probability machines. They're just guessing what the next word is. But because this high-dimensional space, it calculates the distance between each word, it just becomes really good at doing this. So very exciting technology. So why go to all this trouble? Why try and get the best model you can and do all this work? And why am I trying to get this? Because chatbots have a problem. They make stuff up. And they're really convincing when they do it as well. So in some of the stuff, this is not real patient data in case you can see it, but essentially, I was working through a case and the chatbot told me that this patient had progressed when it read its radiology report. And for an oncologist, that's not good. And the patient, not good. It means we've got to change their treatment. It means we've got to look for other options. It completely made that up, but it said it very convincingly. So we can't afford one critical error in any of our practice. So what is the solution? Is it changing prompts? It's going to be a part of the problem. Is it changing the hyperparameters of the model? That'll be part of the solution as well. But ultimately, this isn't about the technology. This is about the whole pathway and getting something to work in the NHS. We can't just get a technology and put it in and say, oh, this is going to save us money and time, watch. We need to develop these within the areas that we're using them. We have to have a framework for evaluating them. We have to understand how we're going to train them and how we use them. We're going to have to run simulations, and we're going to have to work with the clinicians who are going to be using them. So technical feasibility, technical accuracy is one part of the problem, but there's a whole pathway and a whole pipeline before we can start using this technology. And we aren't close to that yet. We can't even get the data yet, and we don't have a strategy for that. So to sum up then, I use this quote from Lewis Carroll to capture the sentiment. So to paraphrase, running to keep up isn't enough. To get anywhere, you've got to run twice as fast as that. And I think we need this technology now. We really do, because we're failing our patients. And this technology is moving so quickly that perhaps, and the NHS, the oncology side of things is moving so quickly, that perhaps with this pace of change, this is the perfect time to try and disrupt the way we're doing things in the NHS. But how we do that is going to take a lot of collective thinking. Thanks, everyone.
Bang on time. Well done, Sam. Brilliant. Of course.
If you're interested in MVP development. Thanks.
doctorsnetcode.com. All right. Oh, geez. Apologies. So our next speaker is Zainab Qazi. She's going to talk to us about bringing more clinicians into AI, and she's a program support officer at Guy's and St. Thomas'. So welcome, Zainab.
Hello everyone, good afternoon. I'm Zainab. I'm a part of
There we go.
Hello, I hope this is working fine. Okay, good afternoon. I'm here to represent the NHS Fellowship in Clinical AI. I was just pondering on this afternoon's topic, that is, vision without execution is hallucination. I couldn't agree more with that. At NHS Fellowship in Clinical AI, we are putting this into practice and turning vision into reality by breaking barriers and bringing more clinicians into AI with a 12-month program integrated part-time alongside their clinical training. This national workforce upskilling project was started in 2021 from a small clinical scientific computing team at Guy's and St. Thomas's Foundation Trust, and is currently run by 4-membered agile team, as you can see, Alex, B, Harris, and I. We are all clinicians from background, and our background continuously guide the improvement and development of this program. This program was built on the recommendation of Doppel review, which first identified the urgent need for upskilling the NHS workforce to safely adopt digital technology, and further was reinforced by white papers such as the NHS Long-Term Workforce Plan and the NHS Transformation Directorate report, and aligns pretty well with the recently released Fit for the Future 10-year healthcare plan for England, which emphasizes on making the NHS most AI-enabled workforce in the world. So the challenge, as you all might already have heard today from other talks and speakers, is time and cost to train these clinicians. The effective use of AI within the NHS requires not only AI experts, but also clinicians with AI expertise to act as the bridge to clinical insights and implementation. Traditional academic routes to these expertise have high financial cost and opportunity cost due to interrupted clinical training. And so what the fellowship is doing is targeting the specific upskilling of our healthcare leaders that sit in a complex ecosystem and interact with many stakeholders with very different perspectives in AI. This makes them both best placed as well as vulnerable in the absence of robust training. So our solution is a remunerated experiential placement with clinical teams that are deploying and evaluating AI in clinical workflow. Fellows are recruited from a diverse clinical workforce and gain experience deploying and evaluating AI in clinical workflow under expert supervision in multidisciplinary team. Our AI projects are focused on deployment and evaluation so that the fellows get the most out of it in their 12-month placement. Our fellowship curriculum is designed around the AI lifecycle and is delivered by multimodal approach and teaching methods. As you can see, each of the AI lifecycle components is delivered by the AI project that the fellow is embedded in, interactive masterclass workshop, asynchronous remote training, and modular e-learning. These workshops are both in-person and remote, hosted by various Center of Excellences throughout the nation. This placement is a 2-day per week placement, and the salary of the fellow is reimbursed to the employment trust by the funders. The curriculum consists of 5 themes and is reviewed yearly by the faculty and updated regularly. The 5 themes are AI fundamentals, regulation and standards, validation, evaluation, integration and system impact, and strategy and culture. And you can see how these 5 themes are achieved throughout their time on the program. Majorly by the AI project that they work on, the workshops that they attend, and the networking opportunities they get via this fellowship. This is just an example project that one of our cohort 2 fellow worked on. It's an auto segmentation on auto contouring tool. So the problem here was clinicians used to spend hours auto contouring tools. This is an example of pelvic radiotherapy, where they used to contour the organs at risk to prevent them from receiving radiotherapy, and the target organs, so that they receive radiotherapy efficiently. So what our AI tool does here, in simple words, is do the auto contouring by itself, and all the physician, a clinician, is left with is recheck it, check it, and then approve it. By evaluating this tool, we found that in case of prostate, the clinician's time, the contouring time got reduced to nearly half, and in terms of cervix and node, it almost decreased to 1/5, which means that the clinician now have plenty of time that he saved by using this tool, and they can use it in terms of building relationship with the patients and other research and developmental activities. These are just some glimpses from our workshop that we hosted across the 4 cohorts, the master classes, and the activities the fellow engaged. Again, a schedule of the fellowship. We meet the fellows at 3 points throughout their time on the program and monitor their progress. We also meet them ad hoc if they have any problem or any issue while working on the projects. This is our UK footprint. Thanks to our sponsors, without whom we couldn't have achieved what we have achieved today. I'm happy to say that we have expanded our footprint to Yorkshire and Humber for cohort 5, which will be joining us in August 2026. And then we welcomed an international fellow as well as part of cohort 4. And a new sponsor that is a digital technology startup called T-Pro is also joining us in cohort 5. Apart from that, we are exploring other funding opportunities to make our recruitment workforce agnostic as much as possible, and also open it up to consultants and other people who are interested in being part of this fellowship via a self-funding route in the future. Hopefully, we'll be there. This is really beautiful. This is our cohort 1. We started with like 11 fellows in 2022, and then we grew to 29 fellows in cohort 3, and now we have a brilliant group of 34 fellows in cohort 4. And we will be welcoming soon, as I said, about same number of fellows in cohort 5, that is August 2026. This is our fellows, you can say, Hall of Fame. Our fellows are from various specialties, both medics, non-medics, which includes doctors, dentists, optometrists, pharmacists, higher specialty scientists, public health trainees, doctor in public health, and physiotherapists. And the faculty is actively doing outreach to involve underrepresented groups such as nursing and midwifery as well. This is our benefit realization paper, which I'm really proud about. If you want to have a look of how the fellowship is delivered, the achievements we have achieved so far, other deliverables, you can scan and have a look. Apart from that, the key things I would like to say is this unique 12-month program attracts hundreds of applications each year. Across its 4 cohorts in total, the fellowship has successfully recruited and trained 91 fellows, resourced about 80 projects across NHS Trust nationally, in partnership with about more than 30 NHS Trusts and teams. these are just our fellows' career trajectories. Majority of our graduates plan to pursue career roles that directly drive NHS AI adoption, evaluation in the NHS. Also, really happy to say that one of our cohort 1 fellow is now an AI supervisor. So that's a full circle of life that we have achieved. Apart from that, our fellows go on to become consultants, work on the projects they are already working on, and also get involved in additional projects in their employing trusts. A few of them have recently joined AI PhDs as well. And these are just some of our fellows' project works that they've been working on, their literature that they have published. The top 5 most highly represented domains of the projects they are involved in are radiology, oncology, cardiovascular, hematology, and pathologies. Again, thanks to our funders and educational partners for supporting our vision and helping us bring it into life. Okay. This is just the recruitment. Yeah. Okay. This is our recruitment timeline, which got disturbed a bit, but let me tell you. Our application for cohort 5 will be opening in November, and then we'll be having a basic recruitment period from Feb till March, where the fellows will be interviewed, and then they will be joining us in August 2026. So if you are interested as an applicant, please reach out to me. You can also reach out to us on gst.aifellowship@nhs.net. You can scan the QR code to gather more information about the eligibility and other Q&As you might be interested in. If you are a supervisor, have an AI project, or know someone who has an AI project, please feel free to reach out to us, and we can see how that can be resourced and added to our project list for cohort 5. And if you're a sponsor and know someone who has funding, want to sponsor a fellow, support fellows in gaining these unique expertise in future-proofing the future workforce in the NHS, please feel free to reach out to us, and hopefully we can collaborate and find a way. Thank you very much.
Right, that was a very interesting presentation, and I think it bridges nicely with the next conversation. I think a lot of people in the NHS don't necessarily understand AI, and when you don't understand it, it's very difficult for you to be creative and innovate with it. And I think one of the easier innovations that I've seen in my practice is the use of chatbots and using Teams Copilot and all of that stuff. So really excited to hear from Phil Hall, Director of Elzware, on chatbots. Are they valuable, inevitable disruptors, or are they dangerous?
Thank you very much. Right, let's just dive in, because I'm sort of graveyard shift here. So this is what I'm aiming at, and what I'm going to do is I'm going to start off quite simply and show you that chatbots aren't new. Yeah, this is a chatbot from 2002 when Coca-Cola had a run at it, Eagle Star had a run at it. My Little Tony was an interesting one. Yeah, this was when we had a position where we were trying to prove that chatbots weren't gimmicks in about 2006, 2005, something like that. So we took My Little Tony and put Tony Blair's head on it, and found that people would flirt with it. Now, they didn't flirt with this one. This is nothing to do with Angela Merkel. This is not an alien. This is a system that I've evolved up to the current day. I built my first chatbot in 1982. I've been building them professionally for 25 years. So I've seen all sorts. I've seen BT do things. I remember the search engine when Ms. Dewey was on top. Are they valuable? Is the next question. And I would say that a chatbot is not just a pretty image of some sort or another with its jade tresses or whatever it might be. A chatbot can be an access point to something of value. And what I'm showing you here is a chunk of code, and that chunk of code turned into a chatbot, and that chatbot helped a group of dancers in Copenhagen have a really cool human-like party. Yeah? Now, that may sound strange. I've done stranger things in my life because I've built over 100 of these systems in various different areas. But the chatbot which was built here to help with this most human party was built in part by a chatbot. The AI itself and the code base was vibe coded by a chatbot. One of the 4-star reviews was given by the same chatbot. Yeah? So is it valuable to be able to move through code, working in Visual Studio Code to create the Nordic Beast, the host, which was, I do have to say, hugely, hugely fun, because it was a playful and thought-provoking dance performance that invites you to a party like no other hosted by an AI. Now, why am I showing you entertainment? I'm showing you entertainment because I work in 2 areas. I work in healthcare and well-being, and I work in entertainment. And the bit in the middle is about behavior modification. Now, a chatbot can change behavior, but if you're going to try and change behavior with a code base, you need a structure. And then you start getting into the recognition of graphical imagery, and you start looking at systems that may or may not be of value and independency. The one which is more like an entity relationship diagram, I had it generated from 2 conversations I'm having with a differentiated GPT-5o across windsurf, yeah, as a coding environment where I'm playing the 2 systems off against each other. Yeah, I'll get to the AIBM in a moment and explain what that is. But let's move on to inevitable. Are chatbots inevitable? Well, if you go back more than 10 years, to 2014, this was a chatbot which was built. It was built long before that became popular, long before generative or neural really existed, before the transformers foundation part of the inverted pyramid, debatably. What this was a system which was built with an animator, and it was about capturing the information for clinicians about kids. How were they feeling? So they're in a game. And the wolf had asthma, so couldn't blow down the house of the little pigs, yeah? So we did geolocation stuff, we piloted it a little bit. Did it go anywhere? No, it didn't, but that was more about people. It was more about people and startup culture and investment. We're really on chatbots here. I'm just gonna go governance versus legislation versus AIBM. Now, AI-BM, note the dash, I wouldn't wanna get into trouble with the big blue, yeah? Is an artificial intelligence benchmark monitor, which also became a bubble monitor, which also became a bullshit monitor, yeah? So I'm gonna touch on that a little bit, but I'm just gonna say that there's an enormous amount in here about governance and legislation and who's selling who to what, and we're not gonna get into it. But if you wanna have some fun and go back into entertainment again for a moment, you'll find that echoborg.com, which was run for more than 100 times, has been negotiating with the human population for the best possible outcome since 2016, all over the place, yeah? So was that a disruptor? It was. I'm hoping the audio is gonna work on this. I've got a video, yeah? A video, yeah? A video, yeah? A video, yeah?
Hello, Peter. How are you, Peter?
I'm all right, I guess. Just a bit annoyed about this whole diet.
Oh. All right, so we're going to stay on AI slop, and I'm going to say that if you go to mimicoach.co.uk, yeah, Mimicoach is a purely generative AI system which we built on the basis of a longer conversation, which I'll share with anybody who's around later on today. I'll tell you why I can't be here tomorrow, which breaks my heart. Sorry about that. But Mimicoach is a generative AI trainer for motivational interviewing. Yeah, purely generative AI, response times in sub-quarter second. Yeah, I would not sell generative AI, and I will tell you why a little bit longer, because it's about slop, isn't it? Yeah. AI slop? Or is it about democratization? Everybody can create an image of Tony Blair on a My Little Pony and do it far better than we did, and they can do it without employing anybody, just using stolen data. Which brings me to, are chatbots dangerous? Yes, they are. They absolutely are. They're dangerous socially, they're dangerous culturally, they're dangerous environmentally, yeah? Where we are right now is that we've got a view that big data is all that there is, data is AI, none of this is true, Yeah, I'm going to suggest a talk that I'm going to give you a link, which I'm running on Saturday, that we do something very radical. And I'm not going to tell you what that is, because I'd like you to see the bigger, longer 45-minute version of this. But data centers and who's running them and what are they doing is a moot point. So AIBM, yeah. I started breaking down what are the benchmarks doing, yeah. I will put this out into some structure, yeah. So essentially what I've done is I've done a negotiation with the chatbot Claude, yeah, and I'm now running it through the chatbot OpenAI to put it into the chatbot Windsurf to create a monitor with real data to show when the proverbial shit is going to hit the fan, yeah. Now, all of these factors here are built into little artifacts, yeah. I'm personally ignoring the fact that it's cost a lot of energy because I don't have kids, right? So I sort of feel like my energy dies with me, yeah? But the idea that there is a quantifiable and real-time analysis of what's going on in the AI market right now and how that bubble will interact with people is a moot point. So are chatbots dangerous, disruptive, valuable, all that kind of stuff? All sorts of stuff. But the nub of it is that generative AI is not the fruit. Hybrid is the fruit. Big data is not the answer. Big data is the danger. Self-sovereignty is the nub of it, I would suggest, from working in this system for 25 years professionally, having had an argument with a chatbot in a virtual world in 1997 when I was studying as an anthropologist. Don't forget the social science in the middle of it. Would you like more detail on this? Maybe you would, maybe you wouldn't. I've been asked to give a keynote talk here on Saturday. I'm slightly freaking out because the amount of information that I want to put into that 45 minutes is legion, and I've been talking to you beautiful people, and you're giving me loads of useful information and so on as well. So, Coventry, generative AI, I will record it, but they've got no money because they're a university, so I'll have to hack it together. That's the end of my chatbot piece. I'm Elzware and Phil D. Hall, and I think the timing is pretty close enough.
You went better than the first one, so well done.
There you go.
All right, thank you so much. We actually have a Rise talk. So Kevin Monk, if you want to come on up. Kevin Monk, for those that don't know him, is the CEO and founder of SARD. And he's going to talk to us about rethinking the EHR architecture. And when I asked him, how would you like me to introduce you, he said, a computer scientist nerdy view from the sideline. So hopefully, there we go.
Cool. Thank you. Hi, I'm Kevin Monk, as mentioned, the founder of a company called SARD. I realise this isn't on the bill, and I'll explain why. Mark said that he had various people kind of drop out, as you often do in these sort of things, and I said, oh, I'll put a talk together if you need it. And then I brought my son along, and I said to him, can you turn this blog post into a PowerPoint presentation? And he did, like some sort of Ben GPT. So I will try and keep it as short as possible. I didn't want him to learn the lesson that we've probably all learned, is when you work hard on a project only for it to get canned at the last minute. And he went, Dad, but I worked so hard on it. I was like, so here we go. I'll try and do it in a few minutes. This is rethinking our approach to electronic health records. My background, I run a workforce modeling company, capacity and demand modeling, but nothing about that. I'm a computer scientist by background, and I don't actually deal with electronic health records. All it is that I have to do them in terms of gathering demand data in. So I'm often looking over the fence and going, what the hell's going on over there? Like, why is it the way it is? So I've got a kind of computer scientist view of it. Has that gone to, he's done lots of transitions. This is EHR as we seem to have it now. You have databases, the apps, and we want them all to talk to each other, don't we? So we have to try and get them all have these API interfaces in between them. That's great, but when you have one single patient care pathway, that ends up being very, very complex, because actually that's not a few boxes. That is the pharmacy, you know, a concerned relative, ambulatory care, the nursing home, the consultant doctor, the patient's nursing home, et cetera, et cetera. And actually those boxes and those apps really start to grow. You know, from one care pathway, off the top of my head, I came up with about 17 just for like one stroke patient, perhaps. That's a lot. So how do we get all of these FHIR fire contracts between all of these providers? Well, yeah, it gets worse. Yeah, it could be all over the country as well, or it could be the fact that you get sick somewhere in another country, so you've got to connect them up all over the world. Great, let's try and do that. Let's have a look and see what that looks like. If you're trying to build an interface between one system, there are 0 connections. If you're trying to build an interface between two organizations, it's 1 connection. 3, I won't go for the whole lot. But you can see it builds and builds and builds till eventually, if you've got 12 nodes on the network, you have 66 connections. If you took a 17 care pathway, the general rule is it's n squared minus n, which would come up for, what's that, 272 interfaces for our, you know, random patient. So it's a big, big number. What if you tried to do it? Oh, it gets worse. It does get worse. Okay, let's try and connect them all. Let's look at how many care provider organizations there are in the UK and try and connect all of them up. Now, I asked ChatGPT, like everyone does, and it said there's roughly about 42,000, 43,000 care providers in the UK, depending on how you work it out, you know, including pharmacies and things. 42,000 connections is 1.76 billion interfaces between all of those systems. It is really hard to build an interface between all of those nodes on a network. Well, we're going to need a bigger app, aren't we? We're going to need a bigger boat, and they tried that. We had the single patient record, which Joe McDonald was a part of, wasting £12.7 billion. Well done, Joe and team. You know, what if we just put it all in one place? Oh, great, that's a lot less interfaces, isn't it? But can I just point out the incredible complexity of mega app in the middle and also mega database behind it? How many apps do you have on your phone? I have about 100. Can you imagine trying to grab, you know, I know you have like BadgerNet in maternity health. Could you imagine trying to grab all of those different types of app with all of their little nuance for different disciplines and different specialties and trying to put them all in one place? This app's going to be great. And it's gone. You know, 12.7 billion lost. Then I spoke to this wonderful man at the back, Marcus, who, now this is weird, he kept me up all night, not in that way. He is a clinician who codes, or also I would also call him a coder who clinicians, because having been a computer scientist my whole life, I'm actually really impressed by the quality of many of the clinicians and the quality of their code and the sort of level of discussion we can have coming from the other side of the fence. So he came up with this thing, and as a clinician who codes, he has also worked on Git. And what Git is, very, very briefly, is a co-authoring tool distributed to distributed co-authoring of records. Does that sound familiar? That's exactly what we're doing with electronic health records. It totally kind of changed my mind about how you could do this. Maybe you could do it that way. Maybe you could have it more file-based, and then you get rid of a hell of a lot of interfaces. When Git came in, it completely revolutionized how we do version control in software. I really think the same should happen in electronic health records. Then I got on a plane, went to Krakow. I went to a kind of gaming software development conference. I came back, I sat on the plane. I told this guy on the plane who was the CTO about Marcus's brilliant epiphany about how to do Git EHR. And he went, yeah, that's good. And then he went, and the two of us sketched out a complete architecture to completely overhaul electronic health records in the UK. And he said, you should look at something called Hypercore. And I thought, that sounds cool. Now, very, very briefly, what Hypercore is a way to do things without any server, without any database, without any mega app in the middle. What you're doing is you're doing P2P, It's a bit like a BitTorrent. If you've used it, you don't just have to use it for pirate videos. You can use it for other things. And it is a way to interface data between systems. Well, that's not even right. There is no interface. There's no interface. The data doesn't sit on a server. It's not in a database anywhere. And you can connect it all up, and we all live happily ever after. If you want to come and chat to me about PAIR, which is a distributed electronic health record system that I'm trying to build up with a bunch of Swiss and Danish software developers, then please do come and talk about it. In short, I think we should change it around. We should start having interfaces between health record systems, and we should do a distributed ledger. And that's it. And thank you, Ben, for putting it together. Cheers, mate.
I mean, I work for a management consultancy, and your son makes better PowerPoints than some of my colleagues. So if he wants to work with us, come and see me. Rightio, so that includes all of the talks, but we do have a little bit of time for Q&A. So if I could ask the people who have presented to come and stand here with me. And do we have a mic that we can pass around? Take the two. Can you take one? Yeah. Oh, there you go. You need more? Hello?
Just turn them down at the moment.
Hello? Oh,
Hello. Thank you for the full presentation. Sorry that I raised my hand because I'm so excited. This is a very nice panel. So is it okay if I ask one tiny question for each of them? Or am I being too greedy?
how many other questions do we have? Does anyone?
One.
Should we go with one for now and then we'll come back to you?
How to pick? Oh my God. Right, I'm going to go with Sam. And you said something that made me red lights all over. So you said that we cannot afford errors from the systems.
Critical errors. Distinction.
Right. Generative AI will make mistakes. There is no way allegedly, there is no way that you can drive the kind of error that you want to minimize. You can, but most programmers can't really understand the AI cycle, machine learning side to do that. So do you understand that? And then my other point is, humans make errors. AI is made with human-generated data. So if you don't want errors or critical errors or any kind of errors that you have a machine that you wouldn't be able to blame, you shouldn't be using generative AI. I think that's my point.
So there's two ways of mitigating that. One is we should be using AI, but there should be a human in the loop. So that's one way.
So more work for the NHS.
But maybe. But the other thing is, when we are looking at errors, so nothing's perfect. There's no CT scan for a CTPA, right, to look for a PE. That's not perfect. That's going to have wrong answers. So what we need to do is we need to risk stratify. We need to have an understanding of what it can do wrong, and we need to build that into our use cases, and we need to think about that. So we're not relying on critical decision makings purely on AI. But that isn't to say it can't be useful. It can be massively useful in the right way, in the right context, with a human in the loop where needed. That's what a PhD's for. That's literally what I'm doing. I'll share it. Thank you.
So this is slightly at Sam, but please for the rest of the panel. So I think across all 4 nations, actually, there is, and certainly in the 10-year plan, there is an obligation on the NHS to be net zero. I forget which 2020 something. There is an obligation for that. What are people's thoughts about use of AI responsibly and its environmental impact, and how that needs to be managed within the NHS, to meet that requirement, basically?
I've got a really good answer for this. So it won't work with the technology as it stands. But the technology as it stands, if you look at DeepSeek, for example, which is the Chinese model, that is far more efficient using a slightly different technology, and we aren't allowed to use that because it's not trusted. But it doesn't mean to say that we can't move towards that sort of thing. And I think that if there's any other answers there, I think, but as it stands, no. No, I do have kids. I have 2 kids. It's really important to me. And actually, I feel guilty every time I'm retraining or any time I'm fine-tuning, because it is using ridiculous amounts of power and energy. Yeah.
Okay, so the answer is no, I don't have kids, although that is a biological fact. Yeah. It's don't just use generative AI. Generative AI was stolen from the internet, and you own your own words. It's all got dropped and trodden on, right? So our game here is to steal it back, lock it down, and the cost-benefit analysis then drops the cost of processing by, don't quote me on this, yeah, but more than 80%. If you don't look at trying to continue to polish whatever it is covered in glitter, yeah, and you look to identify what's important and you put it into an evolved, appropriately dimensionally sophisticated and transparent construct, then you've got the ability to get to a net zero kind of attitude. But you'd have to do something like balance that out on the basis of how much fat you could get people to lose. If they had a good conversation about type 2 diabetes with a chatbot in a hybrid construct, which had less than 80% of the cost of transaction of the conversation. Yeah? Is that a better answer than I don't have kids?
I've got a bit to add to that as well. So the AI lab report, Professor Catherine Creswell is actually one of my supervisors. She's all over the evaluation, as you were saying, how we actually measure this. And we don't know how to measure the outcomes yet. We don't know how to actually see what the benefit is. And actually, there's just short term where you might say, oh, it took less time, or, you know, people, but we don't know how the clinicians who have freed that time up are going to use that time. And we don't know what the long-term consequences of using these things are. And one of the examples I like to use is when I was training, I used to create summaries for the clinical ward rounds. You go around, you look through the notes. It would take ages. You go through all these different notes, you're looking at what's happened, but you learn that way. That's how I became a good doctor. I knew how many times this person had a blood test. And do you know what? They know that. You go in, you're like, oh, you've had 5 blood tests this week. We probably don't need to do one today. We can think about it tomorrow. And then that made me fundamentally, that made me a better doctor. If we take that away, then are we going to just create a load of crap clinicians? Maybe. Go for it.
You mentioned that about how you learn. How much energy did you consume learning that? And yeah, I mean, yeah, it's probably is about 20 watts. And my thought on the net zero kind of question and the energy use is that the technology will just move on, because I don't think brute force reinforcement learning will be the future of AI. I think it will step beyond it. There's a lot of it. I'm personally really interested in something called open-endedness in AI research, which is about systems trying to find what is interesting, which is how we often learn. Or I expected this, I predicted this outcome, but I sensed something different, and the gap between them is interestingness. And therefore, there are people focusing on kind of interestingness in AI. And I think that'll be how we learn, and it'll be much more efficient. It'll be much more like the sort of consumption levels of our brains, rather than requiring a nuclear power plant.
All right, bring it on.
Why should we expect AI to work when we don't have a acceptable list of terms for healthcare?
I think the way that you should do that is you should turn it away from applying healthcare to people, but work out what the terms the person has, and then grow the AI from there. And it's not human in the loop, which sort of has always slightly concerned me on the basis it's not a very pretty acronym. Yeah, it's people in the process. It's a people-driven data, and then the variance of the data. I'm speaking as an anthropologist now. Yeah, same one who had the argument with the chatbot in the bar. Yeah, it's then about human behaviour, and that has the ability to have some construct on it. If you need to then convert it into or you know, whatever kind of construct that exists in the world in a ERP system, that's a different matter. But to engage people in conversational AI, you need to start from the person, I believe, and work out what they call it. Some people might call it this, some people might call it that. Work from human. Sorry, I just literally leapt on that question.
That was a good answer. Yeah.
Hi, got two questions, one for Sam and one for, sorry, the open EHR. Sorry, what's your name again? Kevin. So, Sam, are you looking at screening at all? And if so, is that going to make the capacity problem better or worse? And go on.
I was just not looking at screening. So my specific use case is trying to think about clinical workflow optimization. So what I'm doing is I'm pulling the information of a single patient record out into a clinical summary and basically putting everything in one place using large language models to summarize. So you've got a quick summary of what's going on and you've got the hard structured data pulled in there as well. And the idea is you wrap it in an HTML, CSS, and JavaScript. You put a pretty front end on it, you inject it so that clinicians and patients can both get this record that has large language model powering it, if you like. Okay. But there are use cases absolutely for other things.
And Kevin, having used BitTorrent in the past, sometimes I found that I downloaded things that I wasn't expecting. How do you prevent that in an open EHR system?
Obviously, downloading videos and getting what you don't expect out the other end of them is one use case of that technology. I don't think it's the same case in terms of the P2P apps that we're working on. It's all the routing data between the entities is within the actual peer-to-peer data itself, and including the actual application code. So Keep, which is the kind of messaging app that the pair ecosystem uses, is so light that they, when they first released it, it was kilobytes of data, and it kept getting flagged up as a virus on the system because they were like, well, this must be installing stuff from elsewhere, which it actually was, but it was taking it out of the soup of data in the middle. And so there's a lot of information, including the actual application source code, which sits in this data lake in the middle. I mean, it blows my mind that it's even possible, and I'd love to talk about it more if you have time, but it's not something I'm concerned about. In fact, it's safer in a way because it's all fully encrypted at rest, and you must have the access tokens in order to get to that information. And you can also do things like digital signatures on it to make sure that has come from a known authoritative source about who put that record in there. And you can check that signature against, a known entity, a trusted referee from that data. So, to echo what was said earlier, when you make things open to that extent, they actually become more and more secure. I'm going to get a Whoop Marcus for that.
Hi, this is a question for Kevin, so don't pass the mic on. Kevin, good talk, by the way. Completely agree with the fundamental approach of how to deal with massive, at-scale systems of systems. You can't do it with the IT infrastructure that we have, and if we try and rebuild it that way, we're going to get it wrong. The question I have, though, is whether or not the technology that you've looked at has actually been deployed in massive scale systems of systems, and if so, how did it address the fundamental problem that once you have that massive capacity for communication, the quality of service for each communication entity or activity is actually facilitated and supported given the limitations of the physical architecture for moving that data around?
Is it a question about the
does it have quality of service?
The quality of service. Yeah. I mean, it's a strange concept because there is no server anywhere. Effectively, I mean, it is effectively.
I'm not asking quality of server.
Yeah.
Service. The application requirement for I need the data by this time, or at this rate, or in this quality.
Yeah, well, I mean, the quality aspect comes in the quality of the application that you're fetching out of that out of the peer-to-peer data in the middle. I suppose I'm not. I kind of struggle to articulate it really, but I don't know how to put it really.
Just focus on the time question, right? We've got 100,000, 2 million applications that timeliness of information delivery across a network that could span, huge amounts of geographic area over connections that vary in performance capacity and, load capacity. Given those restrictions, a operating massive system of systems at scale has to manage that. Does this hypercore solution address that as part of its architectural model?
Yeah, it addresses it because the alternative, which is a server-client architecture, means that you are reliant on the quality of that server. So one of the use cases of this is that they're recreating effectively Dropbox. There was a guy talking about the fact that he had a laptop in his room, he had another laptop in his room, and he wanted to send a file from his laptop to his own laptop across a shared Wi-Fi network. And we've all kind of faced that thing, and you put it on Dropbox, and then you're reliant on the quality of the Dropbox service. What if they've got it in AWS Virginia, and it goes down? You're reliant on them. Whereas in the Dropbox service that they've created on the Pair platform, you're reliant on the quality of the application in this distributed network. So if you make a good Dropbox alternative and it's good and it works, then you can send a file across your room without ever touching the network outside, which I think is amazing. That's why they're using it for Dropbox sort of functionality at the moment, because you can just share files from one computer to another without any server at all. It's just mind-blowing to me.
Thank you.
Well, it's similar to AirDrop, but for everything.
Zainab, I'll ask you a question, but all of you can answer. Someone mentioned that we know how humans fail. We know how to manage human failure. We've got systems, laws that are capable, if not perfectly, of doing something like that. I don't think we've agreed the liabilities around a lot of technology anyway, AI particularly, when it fails. What are your thoughts on how we should handle failure? Because human in the loop is basically a transfer of liability. My favorite term I learned this year is liability sink. That is what we're setting up professionals to be. And as you've mentioned, the decline in the learning through training and education, that is only going to grow. I've analogized AI to an expert. We defer to experts. We do what they say. They give fairly generic defensive instructions, which are going to compound the resource implications of the advice given by those experts. And AI just scales that up. So can I have your thoughts on liability and transfer and how we manage that, given we're not prepared for it?
That's a really interesting question, and I'll take back to the faculty. But I think errors and failures is inevitable in life, no matter what you're doing, not just with AI, any innovation or technology deployment. I think that's why we evaluate and monitor these tools that we are building, so that we, under expert supervision, so that we learn from their experiences and make as less errors as possible when you are doing, when you are surrounded by multidisciplinary teams and experts, and you are embedded in a team and not just alone by yourself, you get to learn a lot of skills, share insights, network with people, and also pass down those experiences from your past where you probably might have failed, to not repeat that in the future or in the present from the past. So I think that's my generic thinking around your question. I don't know if I answered it completely, but I'll definitely get back to you if you can reach out to us on email.
May I take in and do an answer as well? So I think the liability should always be with the clinician, because if I Google something and I look at an out-of-date page to get guidelines on managing something, then that's on me, and it should have been down to me checking it properly. And I think we have to recognise that these are tools and they're not infallible, and we should use them in that way. And the same way that we interpret results, you know, you take a result and you make a decision based on your clinical acumen and other things as to whether the potassium is really that high. Do I whack, you know, insulin dextrose in, or do I just take a minute and think, hang on, is this a messed up sample? You know, so I think you have to take the results with an educated and careful manner, but the responsibility is always yours. It's your decision.
So I think I'd go liabilities with the individual. So say you had somebody who came up with a statement like, you don't need radiographers anymore. And a whole load of radiographers cash out and go and get a different job. And then there's a shortage in radiographers, and the diagnosis, because people need to wait longer time, means that more people die. The liability is with the person who said that, I would suggest. I would echo what Sam said about the liability is with the tools, but that means...
No, human, the person.
No, you mentioned in passing the tools and the person. I'm echoing you with the person on the basis of statements that feed the hype cycle, but the tools themselves have been broken on the basis of the precedent that was set when social media got broken. If you allow a set of platforms that have no liability for the content that's on them, and then you enshrine that in a legal construct, which is overwhelming the population of the world, for various reasons, then you need to review that when you try and put the governance legislation around the AI piece. Yeah? So liability fits on there. The dirty route out, of course, is always the disclaimer that sits at the bottom. Yeah? So if you're working in healthcare and looking to do healthcare and well-being, which I do, and I have more people knocking on my door saying, generative AI doesn't work, I need an option, I need it low carbon, then it comes down to, let's not just put something at the bottom that says, generative AI can make a mistake, yeah? Because there's only one correct answer to should I self-harm today, and the answer is always no. Yeah, so the liability is messy, but the problem is that nobody has got the erogenous zones to take it on, and the methodology to get to applying those erogenous zones is somewhat difficult. So, yeah, I get quite irritated by that bit. Yours now, sir.
I don't know about the actual liability question, but on the, you know, the comparison between humans and AI and its tendency to hallucinate and get things wrong, well, you know, humans are effectively big Bayesian prediction computers too, and they also predict things wrong and hallucinate wrong. But in terms of the AI, I think one of the bits that's kind of missing from perhaps the kind of layman use of ChatGPT is that they see it hallucinate a lot. But there are actually things you can do to make them much more deterministic on their output. So there's a lot of stuff around kind of tool use. So you can provide up a set of tools to an LLM and say, here are a set of tools, choose which one to use, and then you will get a deterministic output from it. So one of the examples they always do is like a kind of get weather tool. So you can say to what's the weather in Paris today? And it will look and it'll go, I need to work out what the weather in Paris is today. Oh, I've got one of those tools that allows me to do that. And it'll list through and it'll work out what cities there are. It won't hallucinate a city. It will pick it out of the list and it will fetch it with an explicit function to call. And so you get a lot less hallucinations. It's not going to make something up. And I feel like that hasn't got into the mainstream very much yet. I don't know whether that's your experience.
Isn't that just a voice interface to a search engine?
No, because you're set to talk. So I resurrected my dead grandmother as an AI executive assistant, which is kind of a strange thing to do. But it tracks all of my WhatsApp, all my emails, what my messages. My wife can send me things and say, hey, Marion, go and do this. One of the things it does is if I get a to-do come in, it will try and work out who that to-do is about. So I've got a database of all my contacts on there, like a massive graph database, and it will pick from the tool and it'll go, I need to make a new to-do. And who is it about? And then it will search and it'll go, I need to search your database to find out who this to-do is about. And it won't just invent someone. It won't just create someone. It will look and explicitly call my database and work out who that person is. That's making the whole system much more deterministic on the output, which is really useful and cool. And I think that will end up being more widespread. You'll find that there are more and more tools coming out that are more kind of deterministic and less hallucinations coming out the other end.
Yeah. You can actually, so one of the things, So one of the things I've been using to make sure that, especially when you're giving medical information to patients through a chatbot interface, is they use something called retrieval augmented generation, or RAG. And it's where you can provide the actual document and you can tell the language model, only answer from this, because you don't want it to give information that it's been trained on or that's baked into the models, and it'll only answer specifically if it can find that. And you can use chain of thought prompting. So you can say, only answer from this, and after you've given me the answer, double check it's definitely in that document. And it's like a step, and you can give it steps as well, and you can tell it to double check itself. And that's being used quite a lot to prevent hallucinations. So there are ways. It's never going to be perfect. For you.
Brilliant. So I think that concludes today, and I have a round of applause for our speaker.